Imagine a wave unlike any other, not the gentle rollers you see at the beach, nor even the destructive force of a typical tsunami. We're talking about something far grander, far more terrifying, a megatsunami. These are oceanic titans, capable of reaching heights of hundreds, even thousands of feet. Their power is almost inconceivable. Their ability to reshape coastlines? Absolute. In this video, we'll delve into the awesome power of a mega tsunami, exploring how they form, where they've struck, and the catastrophic impact they leave behind. Before we dive into mega tsunamis, let's understand their smaller, though still devastating cousin, the regular tsunami. Tsunami is a Japanese word meaning harbor wave. These are typically caused by underwater earthquakes, where sudden shifts in the Earth's tectonic plates displace a massive column of water. This displacement generates a series of powerful waves that can travel across entire oceans, often barely noticeable in the deep sea, but growing to immense heights as they approach shallow coastal areas. But a megatsunami is a different beast entirely. It's not primarily caused by tectonic plate movement. Instead, it's almost always triggered by massive, sudden displacement events. Think colossal landslides, enormous volcanic flank collapses, or even the impact of a large meteorite. These events dump an incredible volume of material into the ocean in an instant, creating an initial splash wave that dwarfs anything an earthquake could produce. This initial wave is the defining characteristic of a megatsunami. The energy involved is staggering. Imagine an entire mountainside or a significant portion of a volcanic island detaching and plunging into the ocean at high speed. The sheer kinetic energy transferred to the water is what generates these monstrous waves. Unlike typical tsunamis, which are broad and long, a megatsunami's initial wave can be incredibly steep and localized, particularly near its source. History, though thankfully sparse, records instances of these terrifying events. One of the most well-documented megatsunamis occurred in Lituya Bay, Alaska, on July 9, 1958. This event serves as a chilling testament to their power. An earthquake with a magnitude of 7.8 on the Richter scale struck the Fairweather Fault. The shaking dislodged an enormous rockfall from a mountain face at the head of the bay. Over 90 million tons of rock, an equivalent of 30 Empire State Buildings, plunged 3,000 feet down into the narrow inlet. The impact generated a colossal splash wave. This wave surged up the opposite mountainside, stripping trees and soil to an astonishing height of 1,720 feet. That's taller than the One World Trade Center in New York City. It remains the highest tsunami run-up ever reliably recorded. Miraculously, only 5 people died, primarily because the bay was sparsely populated. 2 fishing boats were in the bay at the time. One boat, the Badger, was carried over a sandspit by the wave, but its occupants survived. The other, the Edry, was sunk, but its 2 occupants were later rescued. The third boat, the Sunmore, disappeared along with its 2 occupants. The scale of destruction within the bay was absolute. Everything in the wave's path was obliterated. Another significant event, though smaller in scale than Lituya Bay, was the 1980 eruption of Mount St. Helens in Washington state. The massive landslide triggered by the eruption generated a series of waves in Spirit Lake, with the largest reaching over 800 feet high. While Spirit Lake is not the ocean, it demonstrates the principle of a massive landslide creating a monumental wave. Looking further back in time, geological evidence points to even larger megatsunamis. One such example is the Storegga Slide off the coast of Norway, around 8,200 years ago. A colossal submarine landslide, likely triggered by an earthquake, displaced an immense volume of sediment. This event generated a tsunami that swept across the North Atlantic, impacting coastlines from Norway to Scotland and beyond. Evidence suggests waves up to 65 feet high impacted the Shetland Islands, and still significant waves reached the coasts of Scotland and even Greenland. The Storegga slide tsunami would have been catastrophic for the Mesolithic populations living along those coastlines. Scientists also study potential future megatsunami events. One area of concern is the Cumbre Vieja volcano on La Palma in the Canary Islands. Geological studies suggest that a significant portion of the western flank of this volcano is unstable. If a future eruption or earthquake were to trigger a catastrophic flank collapse, an enormous mass of rock could plunge into the Atlantic Ocean. Models predict that such an event could generate waves that would devastate the Canary Islands. But the reach of this potential megatsunami wouldn't stop there. Scientists estimate that waves, though significantly diminished, could still impact the eastern seaboard of the United States and parts of the Caribbean, arriving hours later. The initial wave near La Palma could be hundreds of meters high. While controversial and debated, the possibility highlights the global reach and potential threat of these events. The prospect of a megatsunami, while rare, carries immense implications. Unlike conventional tsunamis, which typically arrive as a series of surges, a megatsunami, especially near its source, can be a single, monstrous wall of water. This leaves almost no time for evacuation. The scale of destruction would be absolute. Coastal infrastructure, cities, and entire ecosystems would be obliterated. The economic and human cost would be astronomical. Even in areas far from the source, where the wave height would be greatly reduced, the sheer energy carried by such a wave could still be highly destructive, overwhelming existing tsunami warning systems and coastal defenses designed for smaller events. While the Lituya Bay event saw few casualties due to its remote location, imagine a similar event striking a densely populated coastal area today. The implications are truly horrifying. The potential for such events, even if infrequent, necessitates ongoing research, geological monitoring of unstable regions, and preparedness strategies. Early warning systems for typical tsunamis rely on detecting seismic activity and changes in sea level. For a megatsunami triggered by a landslide or volcanic collapse, the warning time might be far shorter, or even non-existent, depending on proximity to its source. This emphasizes the importance of understanding the geological stability of coastal regions, particularly near active volcanoes or steep submarine slopes. Megatsunamis are nature's ultimate display of oceanic power. Born from cataclysmic geological events, they remind us of the dynamic and often violent forces shaping our planet. While rare, their potential for devastation is unparalleled. By understanding their origins, studying past events, and monitoring vulnerable areas, we can better prepare for a future where these awesome yet terrifying waves might once again shape our world. The awesome power of a megatsunami is a force to be respected, a reminder of the raw, untamed might of the Earth itself.